Hey guys, for your Chapter 8 audio lecture, I wanted to do something a little bit different with you. I feel that it's very hard for me to go through this material without you actually being able to see what I'm doing during the video. So you're going to be looking at my face as I talk through the PowerPoint slides. If you would like, you can go ahead and open up your PowerPoint slides for Chapter 8 and you can follow along with me. As we begin in Chapter 8, Chapter 8 covers articulations. Articulations are anywhere in the body where two or more of your bones meet together. Joints are there to give your body, your skeleton, mobility, as well as help hold your skeleton together. Now, when we first start to think about joints, most people think of things such as a knee or a shoulder, and these are joints that are very highly mobile. However, there are many other joints in your body that do not allow any movement at all. One of the first that comes to my mind would be a joint that's formed between two of your cranial bones. Those two bones are meant to be almost permanently fused to not allow any movement because they're there to protect your brain. The majority of Chapter 8 is involved with classifying joints. We'll classify our joints two different ways. We can either classify our joints based off of how much they can move, or we can classify our joints based off of what they are composed of. The three terms we use to classify our joints based off of their ability of movement are synarthrosis, which we use to describe completely immovable joints, amphiarthrosis, which we use to describe any joint that is slightly movable, and then we have diarthrosis. These are joints that are completely freely movable. As we move now to look at the structural classification of the joints, we can kind of combine these together. Our structural classification of joints includes fibrous joints, cartilaginous joints, and synovial joints. Your fibrous joints are mostly going to be composed of very tough, fibrous material, and they are going to be mainly synarthrotic, meaning fibrous joints are the ones that do not allow movement. Your cartilaginous joints are going to be joints composed primarily of different types of cartilage. Could be hyaline, fibro, either way. And cartilaginous joints are typically going to be amphiarthrotic, meaning they allow just slight amounts of movement. The third structural classification would be a synovial joint. Synovial joints are diarthrotic. They allow completely free movement in many different directions. Under the classification of fibrous joints, we have sutures, syndesmoses, and gomphoses. The sutures are going to be the joints formed between the skull bones. At birth, these sutures are not present. As we grow and mature, our sutures begin to completely ossify and get permanently fused with age. Syndesmoses are joints formed by ligaments. We've had these in our body between our tibia and our fibula, as well as between our radius and our ulna. These are going to be a joint that is simply there to hold two bones together. They are not really going to allow any movement at the point of that joint. The third type of fibrous joint, a gomphose, is only found in the area where the periodontal ligament forms the connection between the tooth and your maxilla or your mandible. Looking at cartilaginous joints, we have two types. We have synchondroses and symphoses. Synchondroses are going to be formed by hyaline cartilage, and we find those in long bones at the area of the epiphyseal plate and in the area of the costal cartilage, which forms between the sternum and the ribs. If you think about why these would need to be slightly movable joints, think about the fact that when we breathe, our rib cage has to slightly expand in order for our lungs to have room to expand and then retract and go down. So we just need a little bit of movement there. That's why we put the hyaline cartilage forming a synchondrose. Symphoses we have seen already in the class. We know the pubic symphysis is formed by fibrocartilage in the area where the pelvis forms. The other place we have a symphysis is in between our vertebrae. Synovial joints are the diarthrotic joints that allow complete movement, And if you will, look with me at your diagram of the synovial joint as I go through. If you'll notice, the synovial joint forms between an area where you have two long bones joining together. We went over in Chapter 6 that at the end of a long bone you have an area of hyaline cartilage called articular cartilage. When a synovial joint is formed, the area where you have the hyaline cartilage continues with an area we call the synovial membrane and then comes back up. In the picture in your notes, you can see this is where the blue membrane meets the green membrane. Inside of the area where you have the articular cartilage and your synovial membranes, that's where you have your synovial fluid. The synovial fluid allows some cushion and gives you a lot of protection in that joint. Around on the very edges of a synovial joint, you have several layers of ligaments and very tough membranes that help to give you the integrity of the joint. As you begin studying that part of your Chapter 8 notes, I recommend that you make you kind of an outline so that you can categorize those together correctly. The reason you're looking at my face in this audio lecture is really so I can go over the most important part of Chapter 8. You must understand these items out of Chapter 8 to be able to move into our next section where we'll be learning muscles. The first slide you have is titled Movements at Synovial Joints, and there's 4 different movements stated there. You need to be able to describe all of those movements and give examples of where you can do that in the body. And I'm about to go through this with you with what I can do with the webcam. Our first set of movements are movements that occur along the sagittal plane. Right? So if you remember from class, we went over the sagittal plane goes straight down the center of your body. Right? So if I'm going to move in this direction, I can either move forward or towards the back. Okay? Now, if you look at my hand, I need you guys to all make sure you understand that the way I have my hand right now, this is considered 180 degrees. Okay? So I'm going to turn it towards you. Now we're going to pretend this is my body. If I bend this angle in this direction, I went from 180 degrees to 90 degrees. So I've decreased the angle. This is called flexion. As I come back from the 90 degrees towards the 180 degree mark, this is now increasing the angle, and that is considered extension. If I go further back, I'm now actually going beyond 180, even extending further. This is considered hyperextension. So if I turn to the side and give you an example using the angular movement along the sagittal plane of my neck, I can bend my head forward. That's considered flexion. Coming back up, that's extension. All the way back, that's now hyperextension. You can generally think of this as hyperextension is going to be the movement that is, I guess, a little more painful out of the group. Okay? You can do the same sorts of movements with the entire body. You can have flexion where you bend completely forward, extension as you stand straight up, or hyperextension as you bend towards the back. I warn you that you go ahead and try to do these movements with your legs because it's a little bit tricky because of the way our knees are formed. As we do flexion of the entire leg, that would be lifting our entire leg forward. As we do flexion of just the lower leg, since our knee can't bend forward, that would actually be bending it from the knee backwards. Now we move next into the angular movements along the frontal plane. And if you recall, the frontal plane is the plane that goes in this direction. It's also called the coronal plane. So we're going to be talking about movements of the body that occur in this plane. There are 3 types of movements along the frontal plane. We have abduction, adduction, and circumduction. And the easy way to remember this is abduction. If you think of abducting someone, you're taking them away. So abduction of my arm would be taking it away from the body. Adduction would be adding it back to the body, so I'd move it back towards my body. Circumduction is a combination of the two, in which you move in a circle, where the word circumference comes from. You could do abduction and adduction of your leg in the same way, Moving your leg out from the side of the body like your arm would be abduction of the leg. Moving the leg in would be adduction of the leg. Next we have rotation. We can do a lateral or a medial rotation. If I do a lateral rotation of my head, I'm going to turn to the side. This is now considering going more towards the lateral aspect of my body. A medial rotation will be turning the head back towards the center or medial area of my body. You can do the same thing with your hands as well as the feet. We have two special movements that we must discuss when we talk about the radius and the ulna. We can discuss supination and pronation. And this may sound silly, but the easy way to remember this is supination is when your hands are turned up, and pronation is when your hands are turned down. The way I remember it is supinate sounds more like supper. If someone's going to feed you, you're going to turn your hands up. So supinate up, pronate down. Supinate up, the radius and the ulna are twisted. Pronate, say that backwards, sorry. Supinate up, the radius and ulna are straight. Pronate down, the radius and ulna cross. Just a couple more of special movements. Special movements of the feet include dorsiflexion and plantar flexion. With dorsiflexion, the foot is going to be up at a 90-degree angle with the lower leg. When you plantar flex, you point the toe down. I always remember point starts with a P. Plantar flex starts with a P as well. Our next special movement is a movement of the foot. You can invert the foot or evert the foot. When you invert the foot, you move your toes more into the medial plane of the body. When you evert your foot, you turn them out away from the body. Our last two are movements of the mandible. You can protract and retract. Protract is going to be, for example, taking the chin and pointing it out towards the anterior aspect of the body. Retract is going to be pulling it back in. And then the last two movements are elevate and depress. Elevate is bringing something up. Depressing is bringing something down. So if I wanted to elevate and depress my jaw, I would depress or elevate. Now, I hope this was not too silly, but I wanted to give you a little bit of a visual feel for how these movements work. I highly recommend that you practice with these a little bit yourself and make sure you understand all of these directional terms. When we get into muscles, we're going to be using these terms to describe what the muscle does. For example, we just learned that if we bend our forearm this way, this would be flexion, extension, right? So we're going to learn that this muscle here, the bicep, is responsible for flexing our forearm, where the muscle back here, the tricep, is responsible for extending our forearm.